Hello, my peeps, and welcome to another Power Packed Phillips podcast. Oh, that was not for my Power Packed Phillips podcast, excuse me. That was because the Heat keep on winning. Yep, I will keep doing that until the Heat finally lose, and then when the Heat lose, I will gonna keep on drinking the haterade, baby. Your MSAs for today, please take a moment to read them. Thank you for all your support. Sawyer met her goal over the weekend. She has now sold over 1,000 boxes of Girl Scout cookies. I don't have a lot of flavors left. Maybe a couple underneath my desk, so if you want a couple, I can hook you up. Otherwise, you're going to have to buy them when you see them for sale in public. Alrighty, let's get started with today's notes. It will be lesson 9.3, Special Products of Polynomials. Lesson 9.3, Special Products of Polynomials. So here we go. If you would, please write down this expression, parentheses 3x plus 4, parentheses squared. They're asking us to find the product. Notice that we have an exponent right here of 2. The exponent of 2 tells you to write the quantity, parentheses 3x plus 4, 2 times. So we're going to write 3x plus 4 2 times because the exponent is 2. So we have this quantity twice. So we can think of we are traveling to Camino, the planet where they make the clone troopers. Nice analogy, Mr. Phillips. So we have to take our clone troopers and make 2 of our clone troopers because our exponent is 2. If the Star Wars analogy just isn't working for you, then you can go with the copy and paste. The copy and paste will also work. What we're going to do next, we are going to FOIL. So we are going to FOIL out, parentheses 3x plus 4, parentheses 3x plus 4. FOIL, pretty easy. This will be the first term. This will be the first term. So we're going to have 3x times 3x. Remember, we got some Casper the Friendly Ghost, so we have an invisible exponent of 1. We're going to add those exponents. So I'm going to do 3 times 3, which is 9, and I'm going to add those invisible exponents. Thank you, Casper. I have 1 plus 1, which gives me 2. So when I multiply 3x and 3x, it's going to give me 9x squared. So I've done the first and FOIL. Now I'm going to do the outside. Outside. On the outside of our lunch table, we have 3x and we have positive 4. So we're going to multiply 3x and positive 4. 3 times 4 gives me 12. And my cute, adorable dog, ruff, ruff, follows me everywhere I go. So that gives us 12x. I've done first, outside. Now I'm going to do the inside. On the inside of my cafeteria table, I have plus 4 and 3x. So I have 4 times 3, which gives me 12. And my cute, adorable dog, or X, is going to follow me everywhere I go. So once again, I get 12x. I've done first, outside, inside. Now I'm going to do last. So this would be my last term in the first set of parentheses. This would be my last term in the second set of parentheses. 4 times 4 is going to give me 16. Now we're going to give them some TLC. My bad. We're going to give them some CLT. Combining like terms. Remember, we are combining like terms. We're done multiplying. Now we're just going to add them. Now we're just going to add them. 12x and 12x are both spies, so those are positives. A 12 and a 12 gives me 24, and my dog X follows me everywhere I go. Then I have 9x squared, and I have 16. Notice I cannot combine the 9x squared with the 16 or with the 24x because this is an exponent of 2, this is an invisible exponent of 1, and this has no variable. So remember to write your answer in order from biggest exponent to smallest. I have an exponent of 2. Casper, our friendly ghost, tells us that's an exponent of 1 that's invisible, and we have 16. There's our solution, but I think it's time for a brain break. So let's take a brain break for a second and see what we have for today. Thank you, Julian, for our brain break. Here's our brain break. Now, for a second there, I thought the guy that celebrated who fell into the stands played for the last place Philadelphia Flyers. Strange. Wonder if block 5/6 could give us some confirmation on that. And the harp is telling us to come back from our dream or brain break. We have one more problem to do today. If you would, please write on your paper, parentheses t plus 5, parentheses t minus 5. And we're going to FOIL this. And then we're going to talk about the sum and difference pattern. The sum and difference pattern. So we will FOIL just like we have been. We have our first term, which would be t and t. So we have t times t. Casper, our friendly ghost, is reminding us there's an invisible exponent of 1. We are just going to add the exponents. 1 plus 1 gives us 2, so t times t gives us t squared. First, now we're going to do the outside. On the outside we have t, and we have -5. So we're going to multiply t and -5, and Casper, our friendly ghost, is telling us there's an invisible coefficient of 1. 1 times -5 gives us -5, and our dog follows us everywhere we go. So we've done first outside, now we're going to do inside. On the inside of our cafeteria table we have a +5 and we have t. So I have 5 times t. Casper, our friendly ghost, tells us there's an invisible coefficient of 1. Nice vocab. Da, Blackhawks. 5 times 1 gives us 5. And our cute, adorable dog, T, follows us everywhere we go. So we've done first, outside, inside. You got it. Last. We're going to do the last, which would be 5 times -5. 5 times -5 gives us -25. Now we're ready for some TLC, some CLT, combining like terms. Remember, we're done multiplying. Now we're just adding or combining like terms. So check it out. I've got t squared. I've got a -25. This guy's a spy for the positives. When I do a -5t and a +5t, those cancel each other out. That gives me 0. So these are going to end up canceling each other out. Now what am I left with? I'm left with t squared and -25. So that's my answer to this problem. Now we go back to the beginning. We talked about the sum and difference pattern. Sum means addition. So notice, we're adding 5. Difference means subtraction. I'm subtracting 5. When I have a sum and a difference with the same number, you got it. When I FOIL it out, they will always cancel each other right here, so I would just be left with 2 terms. That's called the sum and difference pattern. Notice if I were to change this problem to 6, the sum and difference pattern will not work because I have a 5 and a 6. They're not the same number. To have the sum and difference pattern work here, I would have to change this to a positive 6, over here negative 6, then they would end up canceling each other out. All right, as always, thanks for watching. The train will keep on moving. Choo choo. Later, alligator. In a while, crocodile.